it's okay.
All right, it's going into progress now. All right, any questions? Okay, now special D, also you can use this one, okay? 2 times 2 times 2 times 2, that's fine. But when you have this letter, take a look, x times, x already confused, okay? In this case, better use right parentheses, okay? X times, x, or you can use the dot, okay? If you don't want to use the parentheses, just use dot. X dot, x dot, x dot. That is what? Multiplication. Okay, or x. Oh, this is not good idea. Okay, this is not good idea. Okay, this is not good idea. It's okay. When you use about letters, always you need about parentheses or dot. Okay, are you guys with me? Hello. You guys so quiet today. Yeah. All right. So how was your last weekend? It was good?
Yeah.
All right. Very good. Okay. All right. I'm okay. I really feel good because you guys really follow this pre-algebra. Okay. This is very the best one. Okay. I understand, but always, okay, challenging is very important. Okay. Don't fear if you don't know, okay, you don't learn this in your school, don't fear bad, okay? Just challenge a pre-book course, okay? Just always just take a curious, okay? All right, this is a challenge. All right, 4x holding this is repeating numbers, not only 4. So 4x holding is repeating numbers. 2 times repeating is what? 4x times 4x. Okay. What about this one? 4 times. This is a quotient. All right. This quotient also repeating numbers. Okay. So what is that? X over 4 times x over, I'm sorry, not 4, right? X over y, another x over y. 4 times. Okay. That's the meaning. Where is the base number of it? Holding is already base number, okay? The holding inside parentheses, there are base number, not only part of that, not -5. -5 is not base. X is not base. Or 5x is not the base. Which one is the base? -5x. That is holding is the base, okay? This is the base. Multiplication 3 times, -5x and -5x.
It's almost like it's repeating, you know. Repeating.
Yeah, that's the repeating of this number, right? Base number. So which one is the base number? You have to recognize it. H.
5x.
Okay, H, which one is the base number? Anybody can give me base number? Where is the base number, Victoria?
5. Oh,
H. We are doing H.
Oh, 3.
No, not 3.
I think it's plus.
Not plus only.
Dang it. Wait,
X plus 3 is the base, okay? Holding is the base inside the parentheses, okay? So this is the base. Yeah, that's the base. Another base, and twice. We multiply 2 times, okay? That's it. Base can be any numbers. It can be more than 1, more than 3, more than a lot. Okay, maybe you can use what? X squared times 2 over g squared, and over here y cube. This is the base, okay? Now we're gonna learn, okay, how to simplify this complicated base, okay? All right, we did already. Now reverse way, we're gonna express by exponent form. We can see the repeating numbers there, right? First, you have to recognize which one is the base. This is the base. 7 to the what? Multiply 4 times. 7 to the 4th power. Is okay? Or someone use what 7 to erase. Erase. To 4. Erase. This is very correct. Erased. No. I'm not good at English. This is it. Erased. Okay, let me find. Okay. But this is okay. Popular one is what? 7 to the 4th power. Okay. Now this is the base. So 2/3 to the what? 2nd power. Okay. This is the base. Anybody can give me exponent form? Luis, can you give me exponent form of this one, number C?
Number C, I think the 2 over the 2.
2 to the what?
Power 5.
That's right. 2 to the 5th power. Okay, we can say 2 to the 5th power, or just simply write 2 to the 5. That's okay. This will be accepted. 2 to the 5.
Okay.
It's okay. Just say 2 to the 5. It's okay.
That's...
All right. What about the exponent form? Victoria, can you try this one, Victoria?
-10 to the 2nd power.
That's right. -10 is the base. Excellent. That is the 2nd. Okay. -10 to the 2nd. That's perfect. Who's gonna do this one? Brianna, can you try E?
X to 3.
Yeah, X to 3 is okay too. Excellent. Okay. All right. Okay. Brianna, try one more. F.
5y to 3.
Excellent. Very good. 5y is a base, okay? That's to the 3 or 3rd power. Okay, number G. Who's gonna do number G? Is that correct? Okay. Alina, can you try number G?
-3c to the power of 2.
That's it. That's it. Okay. -3c is the base, power 2 to the 2nd power. And you want to try one more, H?
-1/2.
There's no negative.
X.
No negative.
Oh,
F. Oh, okay.
Oh.
Oh, you said that this is not negative, right?
Half
The base number.
X
Okay.
to the power of 3.
That's it. Very good. Okay, everyone understand, I think. All right. Exponent play by certain rules known as what? Exponent product. Wow, there's some rule over here. Operation. Watch this rule. Operation. Something like other number, okay? Addition, subtraction, multiplication, and division. There will be operation over there between the exponent number 2, especially multiplication first. Okay? When you have multiply this one, this is multiplication, but this we have a different power. One is the exponent is 3, the other one is exponent is 5. When you multiply, what happens? 2 to the 3rd power is what? 2 times 2 times 2. 2 to the 5th power is 2 times 2 times 2 times 2 times 5 times. When you multiply this one all together is how much? 2, 2, 2, 2, 2, 2, 2, 2. That's right. This is already 3 over here. This 5 is coming from here. How it looks like it? That change into exponent form again, okay? Because they want to use what in rewrite the exponent form. What is that? 2 to the what? 1, 2, 3, 4, 5, 7, 8. 2 to the 8th power. How do I get this one? When you with the multiplication. 2 to the 3rd times 2 to the 5th power. Always what? Same base number. Base number doesn't change. Don't multiply 2 times 2 is 4. As you can see over here, base number are all 2. Never change. Same base number, just exponent how much? 3 plus 5. How do I got 3 plus 5 from here? 3 plus 5, which is 8. That is one of the what? Exponent operation. In general, I'm going to use it. Oh, over here, this is exponent operation. But this exponent operation always with the same base number. If different base, we cannot use this addition, right? This number we set exponential addition. Only with the same base number. B, same base number, exponent. When you multiply these two numbers, exponent will be additions. It's okay? 2 to the 10 times 2 to the 5. 2 to the what? Same base number, exponent will be added up. 10 plus 5 is what? 15. That's the property. That's one of the property. Okay? Yeah, that's one of the exponential property. This is, we know that 2 to the what? 3 plus 5 is what? 5th power, 8th power, right? One single power, we make it. This is a 2 power. We make one single power. Don't make right 2 times 2. 2 doesn't change. Instead of that, exponent will be what? Additions. Okay, we're gonna have some practice over here, okay? Everybody try number A, B, C, D all together. Exercise 4. The answer number A. Anybody can give me the answer? A.
2
to the what?
2 to the
Go ahead. Yeah, 2 to the 16, that's correct. Because this is multiplication, same base number, exponent will be added up. That's the rule, right? We follow the rule. 5 plus 11 equals 2 to the 16th power. That's one single power we express. Okay. Give me the answer number B.
10 to 11.
Excellent. 10 to the what? 3 plus 8 is 11. Excellent. What about C? Anybody can give me the answer number C?
X to 5.
Excellent. Very good. X to the 5. 3 plus 2 is 5. What about D? Oops. D, do we have a trouble?
Dr. Chung,
Okay, go ahead.
would it be x to the 9 over y2?
Yeah, you can do that. X to the 9 over y to the not 2. 2 plus 1 is 3, right? That's it. Okay? That's it.
Oh, I get it. They're
Yeah.
all 1 when there's
Yeah.
one.
Now, because they have a different base number, we cannot separate. We cannot write, go the next step. That's final. X to the X, Y to the 3, totally different variable. We have to stop it here, okay? Now, if they are equal, we're gonna go a little more step. If this is what X over here, but not X. We're gonna learn this one quotient later, okay? Just right now is the product. Multiplication. Okay, all right, a little more over here. Wow. This is a little more step. Only exponent over here. This is exponent. This is exponent. This is a multiplication, that's fine. But we have a number also included there, right? This exponent has a number, multiplier. Scale numbers in there. This is not like right exponent. Just like right, just numeric number. 4 times 2. This is multiply this 2. That is not exponent. That's why we multiply this number. 4 times 2. Next two is exponent, isn't it? This is exponent because they have the same base number. All right. So numeric operation always simplify. Okay, 4 times 2 is 8. But this is exponent number, base number is the same, exponent will be addition. So x to the 7, that's it. Okay? So you can separate number except what exponent, numbers move to the front. So like the 7 times 2, right? They can separate this way. Y to the 4 times y to the 8, isn't it? 2 times 3 times 8 is y. They can be moved anywhere. 8 times 3 times 2 or 3 times 2 times 8. Same thing, all product. So 7 can move over here. Variable move to the right. But this number is not anymore exponent number. It's just we can simplify because they are numeric number. 7 times 3 is 21. After that, we have an exponent form with the same base number y. Exponent will be addition. What is the y to the what? Y to the?
12.
Yep, 12th power, okay? That's it. Okay, another one. I'm gonna now use some parentheses. Separate, okay? Constant and t squared and 5 constant and t to the 1, right? That is the exponent there, variable. So -2, 5 is a constant. They're gonna simplify with what? -10, right? -10. Now the other two is what? Base number is t. So exponent will be addition. T equals what? Exponent number is 1, right? So 2 plus 1 is what? T to the what? 3rd power. Can you do that, these guys? It's okay? Can you guys do this one? All right, one more, okay? Now, D and F is yours. D, separate, this is a constant, or the other one is exponent. So you can simplify these two constants, 1/2 times 2/5, how much? To cancel out 1/5. Now, take a look at x. That is exponent with base number, x, same base number. Exponent will be addition. X to the what? 3 plus 2 is 5. But remember, when you have number with variable, our mathematical rule, we don't use that. We don't use it. Between number or constant and variable. For example, 2x, that's enough. We don't use the right dot over here, right? That is wrong expressions. Are you guys understood? It's okay? Yeah, that is our mathematical rule. There's no reason. Because that's the rule, we need to follow the rule. Okay? And also you can see over here, 4xy, okay? Variable, number variable, there's no dot. It's okay? Between terms, you can use a dot. So number variable, we don't use that, okay? 7x, we don't use about 7 times this way, right? Okay. All right, we're gonna finish the number EF together anyway, because we have a lot of things we have to finish today. All right, constant, take a look, constant, 4 and 10 are constant, right? This one simplified, 4 times 10 is 40. No, variable, x and x. This is x to the 1. I'm going to put x to the 1 and x to the 3. Only x. Yep, exponent form is x to the 1 plus 3 is 4. Now what about y? Same base number only, okay? Y squared, we have another y squared. Same base number, y to the what? 2 plus 2 is 4, isn't it? That's the simplest form. All right, number f. Okay, I'm going to use the constant 28. Not variable. X2 means well, x to the 1. X to the 1 times, that's all multiplication, okay? All times. X to the 1 times, x to the third power, x to the what is that? 1 plus 3 is 4 over denominator. Still, we have 2 constant over here, 2 and 5. 2 times 5 is 10. Now variable in exponent form, y to the what? 2 plus 2 is 4, isn't it? We are not done. Variable is okay, but still numeric number 28 and 10 can be simplified. It can be divisible by 2, right? 28 divided by 2 is 14. 10 divided by 2 is 5. No more. So the answer is 14 x to the 4th power over 5 to the y to the 4th power. That's the answer. This is we need simplify. Okay. Now take a look over here, number 6. 4x times 5x squared. Yes, that's a product. 4 and 5, that is 20. X to the exponent is 1 and 2 plus 3. That's the answer. All right, now the next one. Wow, this number is open. This is a variable. Variable means what? Open, you said open. The variable, they are waiting some numbers, okay? So when you x is 2, if x is 2, what is the value of that? So replace right x with 2. 2 to the power. They are numeric now. We cannot see any variable now anymore because we take right x is 2. This is, we said evaluate. Evaluate means what? The variable, now the variable has some numbers, okay? Now, when the variable has some numbers, we set evaluation. Evaluation, they are all numeric number. Evaluation, there's no variable. They are all not numeric number. This will be 20 times 2 to the third power, how much? 2 times 2 times 2. This is what you have to calculate, okay? All right, 8. 2 times 2 times 2 is 8. Evaluation means what? In standard form, okay? We need the number, not exponent form, okay? So 160 is the answer. We just evaluate. Memorize, okay? Evaluation, there's no variable. Okay, only numeric numbers. Are you guys with me? Okay. Now we're gonna jump over here, right? It's the same thing. Just one more practice, okay? Just one more practice. Watch the answer number 8. Anybody can give me the answer over here. 10 to the 5th power times 10 to the 2nd. Same base number, exponent will be addition. Everyone know this one. What's the answer to this one, Aliana?
Will it be 10 to the 7th?
That's right, 10 to the 7th is correct. Okay, okay, just one more B.
Me?
Yeah, B, try it one more, Aliana.
X to the 8th.
Excellent, that's the answer, right? Very good. Good job. Okay, now who's gonna have next? Louis, you wanna try C?
Okay.
Exponent form.
Is it y equal 4?
No, this is the
Five,
one over
five.
here. Oh, 5 is correct. But again, y to the 5, but correct name is y to the what? Pips.
Sorry.
Okay, that
I
is
forgot.
better. All right, now another next property. Wow, another property over here. Okay, another property. Over here, x to the y, inside we have 2 variables, but outside is 3. This one can be separate, this one. X also a cube, y also cube. This we said kind of what distributive property. 3 times 1 over here, 3 times y to the 1 over here, right? Okay, because actually looks like this way. X to the 1, y to the 1. When you have exponent, this exponent, multiply these two exponent. So x to the 3rd power and y to the 3rd power. This number 3 distributable inside the number 1, right? This is we said product. Okay, product rule. This is we said product rule. All right, so we're gonna continue using the product rule. Division also same things. This one over here, 1 over here. Okay, using this one, I'm gonna use right exponent form separate. X to the what 3 over this times over here y to the 3. Okay, you have to memorize. Okay, that's the rule. This is exponent. What is that? This is actually what the xy times. This is base number xy times xy. How many x there? 1, 2, 3, right? Repeating x is times 3. Y also repeating what? Times 3. Okay, you can separate. X 1, 2, 3 is y, x to the 3rd, y is 1, 2, 3, y to the 3rd power. Okay, this is also same thing. X over y times x over y times x over y, 3 times. But when you make all of here, numerator first, x times x is what? X cubed, y times y is y cubed, right? This is just the same as this one. So there's a rule over here, one of the rule, general properties. When you have this one, distribute a to the what? N times b to the n. That's the rule. N can be any numbers. So the next one, over here, we do it before, 1, 1, right? So a to the 1 times n is this is a to the n over b to the n, right? That's the formula. Can you guys remember this one, right? That is second formula. This is third formula. First formula, we already did this, okay? X to the a times x to the b. This is the first one. X to the what? A plus b. That's the first one. That was first one. This is second one. This is third one. All right, now let's have practice. 5x squared. Just the express form. 5. Actually, you got the 1 over here, right? So 1 times 2, 5, 2 times x2. It's okay. But in this case, we don't have to write down that. 5 squared, x squared is enough. The next one. 1 over here, 12 cube and y cube. That's it. Can you change the form? You just separate, all right, inside the parentheses. -2, this is also what you can change this one. -2 and n, okay? Look at this way. So what is that? -2 to the what? 5th power and n to the 5th power, okay? You can separate this way. What is the d? 1 over here, 3 to the 4th power over 5 to the 4th power. That's the rule. Is what is that? N to the 3rd power over 4 to the 3rd power. That's it. F is what? 10 to the 2nd power over x to the 2nd power. That's it. Now we're gonna have some practice, okay? Okay, this one, okay, we're gonna have practice. After this, after the 2 4, what is this one? 2 times 4, right? We did it. This is we said exponent of exponent, 2 times 4. Because what? This is where x squared, the repeating multiplication is 4 times. X squared, that's 4 times. So by using the first right operation, 2 plus 2 plus y, when you have right multiplication, 2 plus 2 plus 2 plus 2 is what? 4 times 2, isn't it? 2 times 4. That's why we got what? 2 times 4, we are not 2 plus 4. Exponent of exponent is multiplication, okay? So x to the what? 8 is correct. This is exponent of exponent multiplication, x to the what? 15th power, that's the answer. This is said the exponent operation, one of the exponent, x to the what? A times b, a, b, isn't it? That's the formula, right? You have to memorize this one. Y to the 4th power 11, how much? 4 times 11 is y to the what? 44 is the answer. Now we're gonna have some practice of it. There are 6 questions. Everybody try A, B, C, D, E, F. Okay? All right. You're gonna write this one in simplest form using properties of exponent. Okay. Everybody try A, B, C, D, E, F. Okay, we'll check the answer later. I'll give you some minutes, okay? But you don't have to evaluate. You don't have to simplify just by using exponent. That's enough, okay? For example, exponent. This is one over here. What is that? 5 to the what? 1 times 2 is square. X to the what? 4 times 2 is 8. That's enough. But if you, this is what numeric number, 5 squared is 25. If you want this one, you can write this way too. But this form is okay. They want you to use what this form, okay? All right, finish number up to the end, okay? All right, anybody has the answer number B? You just separate inside, okay, number 10 and y squared. Victoria, you wanna try?
Yeah, I'm
Oh.
not sure this is correct, but
Okay.
I got 10 to the power of 3 and then y to the power of 6.
That's right, that's the correct answer. Because 10 to the 1 over here, right? So 3 times 1 by the rule, 10 to the third, and the y to the what? 2 times 3 is 6. Exponent of exponent is a multiplication over here, okay? This we said exponent of exponent, always about multiplication. Multiply the numbers, okay? All right, who's gonna do C? Separate. We have a numeric number -2. It doesn't matter. It can be negative number. Anybody can try this one? Line up. I wanna try that.
-2 to the power of 3.
That's right.
and-
Excellent. The next one.
And n to the power of 8.
No, this is a multiplication.
Oh, so
Okay.
then 15?
Yeah, 15. That's different. Power to 8 looks like this one. 10 to the 5 times 10 to the 3. Yeah. Same base number, exponent will be addition, right? That is 8, but this one is what? Different. 10 to the 5 to the 3, isn't it? It's okay? But actually this is equal to, if you want to express this way, 10 to the 5 times 10 to the 5, I'm sorry. Not m. N to the 5, another n to the 5, another n to the 5. This is what? N to the 5 plus third power, isn't it? But in this case, now you can apply this one. Same base number, you add what? The exponent, okay? So 5 plus 5 plus 5 is n to the 15, right? A little bit different, isn't it? So in this case, that was multiplication, not addition. Okay, that's what we said, what? Exponent of exponent is multiplication, okay? All right, who's gonna do number D? Any volunteer? Just give me the answer. Go ahead.
X. Oh wait. X to the 10th.
That's right. X to the 10. What about denominator? Oh, this is y there, right? Y1. 9.
9 to the 2nd.
Second, right?
Oh.
1 times 2 is the second. That's it. Okay. Maybe later you can simplify the 9 squared is 81, but they're gonna leave this way, okay? In exponent form. Who's gonna do E?
I can do it.
Oh, sure. Yeah, you can do it. Okay, go ahead.
1 to the 5th
Okay, 1 to the 5th power is 1.
over x to the 40th.
Excellent. That's it. But 1 to the 5, you can simplify. 1 to the 5 is 1, okay? Just 1 over x to the 40, okay? Excellent job, Luis. Very good. Who's gonna do F now?
Can I try?
Oh, sure, yeah.
2x,
Now separate.
would it be 2 to the 3rd power
Very
over
good.
5 to the 3rd power?
Yeah, 2 to the 3rd power. What about x?
X to the 6th power.
Very good. And what about down there? 5.
5 to the 3rd power.
Excellent. That's the answer. Very good. Yeah, this is what the second we have right front and the back of pre-algebra. Okay, that is not easy one, but you guys can do right. Excellent job right now. All right. So we're gonna do You guys learned this already, okay? I think we don't need an explanation there. I think you guys can do that. Okay, keep going. The next one, okay? All right, the next one is to simplify the numbers. This is what you guys know already, right? 10 over 10 is 1, 17 over 17 is 1, negative divided negative still positive 1. This is, we can't just what? N over N? No, N same number, N divided by N still 1, okay? This is one, same number, numerator and denominator, always 1, okay? That's the rule. Okay, any numbers divided by itself, it is equals to 1, okay? In other words, same thing, any fraction whose numerator and denominator the same or equals to 1, okay? We just simplify, this is, you guys know already, I'm not gonna do everything. Just simplify over here. First one, to simplify, you need to find the greatest divisor, which is the greatest common factor. 12 and 20 there. What is the greatest common factor? 4, isn't it? 4. It's okay. You can divide it by 4, both sides. Divided by 4, divided by 4, you get what simplest form. 3 over 5, isn't it? This number 4 is called what is the greatest common factor, okay? GCF. You know how to get the GCF, right? You can use this letter. Letter means 12 and 20, just divide some numbers. 4. 12 divided by 4 is what? 3. 20 divided by 4 is 5. No more between this number, no more common number. So this number is greatest common factor. Okay, this is the greatest divisor, same thing. Okay. All right, just simplify the fraction. You guys know this already, right? I'm not doing this one. You can have some practice of it directly. You have some practice, okay. Okay, give me the answer. This is, you guys know already, okay? 9 over 9, 1, same number, 1. This is the same number, 1, same number, 1. Cancel out. Now, the simplest form, 4 over 3 times 1 is what? 4 over 3. Same numbers. Now 8 over 9 times 1 is there. 8 over 9. Oh, this one simplified, okay? Because 5 over 5 is 1, isn't it? So 3 over 7 is the answer before you multiply. 8 and square, this is a canceled out, same number, already 1. We know that. That is 8 over 11, isn't it? 7 over 7 is 1. We know that this is 1. It's going to be 1/3. 5 over times x over x. This is also 1. X over x, same numbers, always 1 still. This is 5 over 1 is 5. This is just simplify, same numbers. When you got this x is 5, 5, same numbers. This is 1. Just what? X cubed, isn't it? This is the same numbers. It's going to be 1. Y, 1 over y cubed is the answer. Okay? But this is a numeric number, you know that. So to simplify exponent, we use one of the skills that we use this method. Y to the what? Any number, n over y to the n always equals to 1. Right? Same number over same number equals to 1, isn't it? So I'll show you over here. This is another rule, but this is okay. Another rule of the exponent, okay? Exponent. Okay, maybe there's another rule, but we're gonna try this one, this method first. Okay, using numerator, denominator equal, they're gonna be 1, okay? Okay, this is a 7 square. You can say different, this is 7 to the 6th power is what? We're gonna create what? 7 square. So all the other one is a 6 minus 2 is what? 7 to the 4, right? But we can rewrite 7 to the 6th power is what? 7 to the 4th power times 7 to the 2nd power. Now denominator is what? 7 to the 7th power. You don't need the 1, okay? But this is how much? 7 square over 7 square, they're gonna be 1, isn't it? Same numbers. Binary, we have a right 7 to the 4th power. We don't need this one. Are you guys with me?
Yes.
X to the 3rd power of x to the power. We're going to eliminate this small one. We make this one into 2 terms. One is the same exponent number, x to 3. The other one is 2, isn't it? The total is 5. But this number, we know that 1, right? X to cube over x cube, same number, it's going to be 1. What is the result? 1 over x squared. 1 times 1, we don't need to multiply by 1, right? So using this one, I'm going to do this one. This is 3. We're going to express this one, okay, in 2 exponent. One is 10 to the 3 times. The next is 10 to the what? 7 minus 3 is 4, isn't it? Are you guys with me? Okay. 10 to the 3rd power times 10 to the 4th power is 10 to the 7th power. We just separate this one, okay? But this number is 1. I'm going to 10 to the cube over 10 to the cube separate, and another one 10 to the 4th over 1. This number is 1. Numerator, denominator, they are same numbers. When you use a division, right, between same numbers, it's gonna be 1. So 1 times nothing, just what? 10 to the what? 4th power is the answer. All right, number D over here. Still, we're gonna use it, but there are another way, okay, to simplify, okay? Maybe later we can use that later. But this one is just how we simplify, okay? How we simplify division of exponent number. I'm going to separate the 5 to the 7th power with the 5 to the 6th power times 5 with the 4th power, isn't it? Separate. Because we need, right, eliminate these numbers, 5 to the 6th power. So this one is how much? 1, isn't it? 5 to the 6th over 5 to the 6th is 1. We just got the 1 over 5. That is 1 over 5 is the answer. Now choice is, take a look. I'm going to express y to the 9th power in y to the 4th power. 9th power separate is y to the 4th power times y to the 5th power, right? 9 minus 4 is 5. You know that 4 plus 5 is 9. So y to the 4th power in bottom there. This y to the 4th power, y to the 4th power is going to be 1. Okay, 1 times y to the 4th. What is it? Nothing. Just by itself, y to the 5th power is the answer. Are you guys with me? Okay. Now this is 3rd power. This is greater than 3, right? So we can break the bottom with what? 3rd power. But 12 minus 3 is what? 9, isn't it? But this 3rd power can be canceled out with what? Top n cube. That's gonna be 1. So 1 over n to the 9th power. Okay. This is how much? 2 to the 6th power times another 2 to the 6th power, total is 12. 2 to the 6th power, this is gonna be 1. We have right 2 to the 6th power is the answer. N to the 10th power can be separated. N to the 2nd power times n to the 8th power, but this m 2nd power canceled out with the m squared denominator, 1. 1 times n to the 8 is what? Just n to the 8. Okay, I'm going to finish the last one, okay? This is a cube. This is what divide a cube and a second power. That is a to the fifth power. But this one will be about 1, isn't it? So 1 over a second power is the answer. Is it okay? All right. Number 6. 5 to the 11 is about 5 to the 9 times 5 to the second power. That is 5 to the 11. 5 to the 9 is canceled out. The same number is going to be 1. This is a 1. 1 over 5 squared, right? That's the answer. Okay, 5 squared, they evaluate. Okay, 5 squared is 25. Now, there's the rule. When you have a division, we just use division over here, right? What happened over here? How do I get the 5? There's the rule here. When you have a same exponent, 9, you're going to subtract, okay? Always subtract. 9 minus 5, 9 minus 4, that is 9 to the 5. Can you see that 5? This one, D is 5 to the 6, 5 to the 7. But this 7 is greater than 6. Okay, so we're going to check root. Minus 6, isn't it? The other side. So 5 minus 6, 7 minus 6 was 5, but still denominator. That is what subtraction. Okay, now look over here. That is, the rule is 5 to the same base number when you have a quotient, 5 minus 2. Just before we have this one, 5 to the fifth power times 5 to the second power. When you have a right product, product is what? Exponent will be addition, 5 plus 2. But when you have a division over here, okay, that is division. A to the fifth power and divide by A to the second power. That is division over here. That is a subtraction. Multiplication, addition. That's the difference. 5 minus 2 is what? A to the third power, isn't it? Another one is we know that A to the fifth power, we're going to divide by into a second power, a third power, right? A to the what? Second power times A to the third power. Denominator A to the second power. This is 1, but we say A to the third power. You can solve this way from now on. Better use what? Exponential operation. When you have same base number and division, exponent will be subtraction. That is okay? Remember, totally different. Multiplication, exponent will be what? Addition. Subtraction is where exponent will be subtraction. This is division, same base number 5. 5 to the what is it? 11 minus 4, which is equals 5 to the what? 7th power. That's it. Same base number, x and x, that is division. X to the what? 6 minus 2, that is subtraction. X to the 4th power is the answer. This is the same exponent, x, and x, same base number, always the subtraction a minus b generate. That is the formula. What about this one? We know that this is a 1, right? How do I get the 1? 2 to the what? Same base number, 3 minus 3 is what? 3 minus 3 is 0. 2 to the 0. 0 power over any number, always 1. Okay, so any number 0 power or always 1. That is another formula. 100 to the 0 power, 1. 2 to the 0 power is 1. Million over 0 power is 1. We said 0 exponent. When you have a 0 exponent, the value of this one is 1. Okay, you have to memorize this one. All right, over here, they said 0 exponent. This is 1. Any numbers, it can be any numbers. When you have a 0 exponent, already 1. What about this one? This is 0? No, x0 is opaque to only this one. 5 is what? Outside, that is independent. Okay? So 5 to the y. X0 is how much? That is 1, right? Any number. This is 5. Don't forget that if you got this one, 5x, the whole thing is 0, that is 1, okay? But this is different, totally different. They are not equal. Okay, we have a parenthesis, 0 power is what? Affect all 5x, but this is 0 is affect only x, not 5. 100 to the what? X to 0. That is 100. X to 0, this is only 1. Now, what about this one? 100 x to the whole together 0 power, yet this is definitely 1. Different, okay? Okay, now I'm gonna finish this number page 3, right? Using 0 exponent. 25 0 is 1. This is 1. Any number is 1. Any number is 1. What about this one? Wow. 0 to the 0 power is 0? How do you think? Oh, I don't think so. Okay, maybe we might have some help from calculator. So let's see. Calculator recognize this number. 0 to the 0 power is not 0. I think so, in my opinion. But what about you? 0 to the any number is always 0. 0, I'm going to say 0 to the what? Power of 7. 0 times 0 times 0. 0 power of 7 is what? 0 multiplied 7 times. That is 0. We know that. That's true. But 0 over 0 power, 0 to the what? This is 0 to 0 power. It's going to be 0? No way. Okay, let's see. Oh, undefined error. Because the calculator doesn't recognize, okay, doesn't get the right, provide the number of this one because there's no number up there. So 0 to the 0 power is undefined, okay? Undefined, there's no number. We don't know. Okay. Okay, we're gonna, after some break, we're gonna continue negative exponent. This is very important. When you have a negative exponent, what am I gonna do? Okay, right now to 4, everybody come back here to 15 p.m., okay, after 10 minutes break. Okay, we'll continue the work. Okay, I'm gonna stop the video. Just presume pause video. Okay, sorry, this is now recording in progress. Okay, sometimes I forget this one. I forgot this. All right, now we work, maybe eat together. The rule, quotient, is what the exponent will be. Subtraction, do you remember? This one is actually should be like this one. 4. Subtraction is -1 minus 3. That's it. Okay, that is subtraction. -1 minus 3 is a -4, isn't it? -4. That's final, but not yet, because we have negative exponent. We need to change into a positive exponent because that's the rule. The rule or law we have to follow because somebody made this one. Somebody wants to do this one. Okay? We need to follow the rule. Negative number, this one should be 1/4 to the what? 4th power. That's okay. Maybe you can evaluate this number, 4 to the 4th power, how much? Anybody understand 4 to the 4th power, how much? Okay, you guys memorize some squared numbers, okay? Later I show you. up to the what? 20 times 20. If you are going into 9th, 8th grade, then around what? 30 times up to 30 times 30. For example, 1 square, 2 square. Oh, you know that. 10 square. Yeah, this already know that. What about 11 square? You have to memorize because you are smart. You need to memorize 12 squared how much? 144, 13 squared how much? 169, 14 squared how much? 196, 15 squared how much? 225, 16 squared how much? 256, 17 squared how much? 289, 18 squared how much? 324, 19 squared how much? 361, 20 squared, 400. You need to memorize up to here. Up to here. If you want to be smart, all right. Now we're going to try number app again. This is 5 to the 1. 5 is 5 to the 4 because we're going to apply exponential operation, exponent operations. That is a quotient or divisions. Exponent will be what? Subtraction, right? This is still 5 to the what? 1 minus, oh, this is minus again. Don't forget this one. Not only 1 minus 2. 1 minus minus 2. This equals how much? 1 minus minus 2 is what? 1 plus 2. Actually, this is about 5 to the third power. The no more exponent. This is 5 to the third power because this number is greater than negative 2. No problem. Only numerator was smaller than denominator exponent. Now you're gonna go one more step to make it positive. Are you guys with me? This is about operation, one of the first one, right? 10 to the what? That is a product. We're gonna add this one, negative 3 plus 5 equals 10 to the what? Second power, which is 100. A second one is a little bit different. Negative number is more dominant. Negative 8. 5 plus negative 8. This one is about 2 to the what? Negative third. Isn't it? Negative 3. But we are not done because it has a negative exponent. To make a positive exponent, always what? 1 over minus means what? This one, 1 over. That's a bar extended. 2/3, the other one 2/3 that go to denominator. Are you guys with me? Okay. This is regular operation. Exponent will be addition. Plus 2. 5 to the what? Minus 2 plus 2 is 0. Oh, this is 0 exponent already 1, right? What about number D? 2 to the what? 2 minus 5. Okay, there's subtraction, 2 minus 5. But this 2 minus 5 is what? Negative 3, right? 2 is smaller than 5. It's going to be negative 3. But we need to change into positive exponent. 1 over minus this number, change this bar, 1 over. Exercise 3. 7 to the what? Negative 1 minus 2. That is quotient. Negative 3. But that is not positive exponent. Change into positive exponent to 1 over 7 to the third power. 7 to the third power is what? 7 times 7 times 7, right? You guys know that 7 times 7 is 49, and another 7 is what? 343. They evaluate. You guys follow me, right? Okay. Now this is about exponent over exponent, always multiply. That's the rule, okay? Don't think the reason. We proved already. Exponent of exponent is multiplication. 2 to the negative 1 times 3 is how much? 2 to the negative 3, okay? But we're gonna change into a fraction, 1 over 2 to the 3, that's it. Or you can evaluate, 1 over 8 is the answer. Or before you multiply, you can change this one positive exponent. That's another way too. 2 to the negative with 1 over 2 to the 1, right? That is 2 to the negative 1. After that, you can multiply third power. 1 to the third power is still 1, 2 to the what third power is 2 to the 3, right? Still, we have the same numbers. Okay? All right, you can use any method. After I multiply everything, you can change into positive exponent. But when you can change into positive exponent, after that you can apply fraction. I like for you this one, multiply first. For example over here, negative 1, I'm going to this one. Negative 2 times negative 1 is about 5 to the 1. Negative 2 times negative 1 is positive 2, right? You don't have to change it. Just 5 squared or equal 25 is the answer. Okay, everyone try number A, C, D, E, F. Okay. I'll give you 2 minutes, okay? First, you apply exponent of exponent, which is a multiplication. After that, when you got negative exponent, change into positive exponent. Almost done, okay? If possible, we're gonna try another topics. So that means what we're gonna cover almost 85% of pre-algebra. But actually we didn't do probability still. We did it? No, not yet, right? But almost 85% or 90% we covered over pre-algebra, okay? All right, what's the answer number 8? Anybody has the answer number A? 3 to the negative 1 to the second power. Okay, Victoria, can you try this way? What's the answer?
I'm not sure it's right, but I got 9.
You got 9, okay. 3 to the negative 1 times 2 is a negative 2, right? It's okay?
Yeah.
We got the negative exponent. Can you change in the positive exponent? 1 over, what is that?
Oh, so it'll be 1 over 3 to the second power.
Yeah, that is not 9. 1 over 9. It's okay? Or before you multiply 2, you can change this one in fraction again. 3 to the negative 1 is 1 over 3 to the 1, that is 3, right? After that, you can make a square. You got the same numbers. What about C? Oh, 7 to the power times 0, what is that? 7 to the 5 times 0 is still 0. This is always 1. 0 exponent of any number except 0, always 1. What is this? 4 to the what? Negative times 2, right? Always this is a multiplication power exponent of exponent multiplication. Negative 3 times 2 is a negative 6. Now we still have a negative number. We're going to change it to positive number. 4 or 1 over 4 to the 6th power. You can leave it this way too. A to the 0th power minus 4. 0 times negative 4 still 0. 0 times negative 4. 0 times any number always 0. This equals to h to the 0th power. 0 exponent of a number will be 1. All right, this one is 2 times exponent of multiplication, negative 4 times negative 2, negative 4 times negative 2 equals positive 8. This is already positive 8. How much is 1? You can calculate, or you can leave it this way, 2 to the 8, which is what, 256. All right, one more time, simplify inside the first. 3 to the 1, negative 5 plus 4, right? Product is what you can add these two exponent. Negative 5 plus 4 is 3 to the negative 1, isn't it? Inside the parenthesis, 3 to the negative 1. Now, exponent over exponent again. This time, you're going to multiply these two numbers. 3 to the 1, negative 1 times 2 is a negative 2. We still have a negative exponent. We're going to change this to positive exponent. 1 over 3 squared. That is equals to 1 over 9. Okay? Same thing. Okay, when you simplify, we can express this 1 over n, some value of n. First, this is the exponent of exponent with multiplication. 2 to the what? 3 times negative 2 is negative 6, and times 2 to the 1, right? Same base number, 2 is 2 to the what? We're going to use the exponent operations. That is multiplication, exponent will be addition. Negative 6 plus 1 equals negative 5. It's okay. Negative 6 plus 1 when you have multiplication with the same base number. But this is still negative number, change into positive exponent 1 over 2 to the 5th power. That is equals to 1 over n, but they're going to follow. They're the exponent, right? We're going to calculate this one. 2 to the 5th power, how much? 32. It's okay? 2 times, 2 times, 2 times, 2 times 2. That is 2 to the 5th power. 4 and 4, 16, and times 2 equals 32. So 1 over 32, but in this case, n is exactly equal to this number. N equals 32, which is the answer, okay? So we're gonna have some practice over here that will be on your homework, okay? Okay, there'll be no problem, almost done. We did almost done. Okay, just this one, inverse operations. Okay. This one is inverse is what is it? When you choose what plus, when you choose a minus, that's the inverse operation. Plus minus inverse operation. Okay. And multiplying and division also inverse operation. Okay, that's it. Because you guys know this already. I think this is, you don't need this one. That's fine. Okay, oh, this is square root. Oh my God, let me see. All right, now I'm going to explain what is the square root. Okay, square root. The square is what? You have two numbers. This is square. This side is 5. The other side also 5, okay? What's the area of this one? Area A equals what? 5 times 5 is 25. Okay? So area, I'm going to use this one. 5 times 5 equals 25 is the area. Now this side of a square, which has whose area is 25, this is 25 is area. So this number of side is called what? Square root. That's the formula. That's the definition. This is square root. The length of each square side. The length of each side of a square is, we say, square root. 5 is a square root. Okay, 5 is the square root of 25. So square root, another expression is what? Square root of 25. Okay, if we area is 25, this is square root. We use these symbols. So instead of 5, when you have a 25 over here, oh, this length is square root 25. This length is square root 25. That's it. That is our definitions. So we know that the square root 25 times square root 25 must be equal to 25. Because with 20, square root 25 is 5. Square root 25 is 5. Okay? But when you have this one, but this is, you know that this is a perfect squared area, 25. Each side is 5. Each square root will be 5. What about this one? If we have a 10 over here, what is the length of this side? 3 times 3 is 9. You never make a 10. That's why we use square root. By definition, we use this side is square root 10. The other side square root 10. That's our definitions. So our rule is, what is that? The area should be square root 10 times square root 10 should be this area, right? There is our definitions. So if two numbers is equal, this is also what you can put in the inside there. 10 times 10, that is why equals 10. When you have two numbers equal inside the letter, or two square root over here, always what? Give us what? By itself, which number is 10. So definition is what? Square root 12 times square root 12 is what? 12, that's it. This is our definitions. When you have over here, if we have this one is 49, what is the square root? Square root means this side we set square root. 7 and 7, we know that. By definition, we use instead of this 7, we use square root 49, square root 49. Okay, that is our definition. So square root 49 times square root 49 is 49. But we know that this square root already was 7, right? 7 times 7 is 49. So square root 49 is equals 7, same thing. But we know that by definition, square root 49 is 7 times 7, right? So same number, square root 7 times square root 7 is still 7 by definition, it should work. But sometimes the area is not square, perfect square numbers. When your area over here, 13, that's the area. This is squared, all sides is equal. What is the length this side? There's no integer number satisfy this side. That's why we use square root. That is definition is what is that? This side is square root 13. That means the length of this side. This side is square root 13. That is our definitions. But we know that square root 13 times square root 13 should be this area, right? That's it. What I got? When you multiply square root the same numbers, now square root is gone. Just what give us area 13. It's okay? This is a square root. So how can you simplify square root? Square root, same numbers. I'm going to do the same numbers. X and X multiplication. This is X. That's a square root. Back to work. Take a look over here. We're going to simplify the square root. This is square root of 9, but still we continue simplify because of square root. If they have right the square numbers inside, they're going to be simplified. Square root of 9 is what it is? Square root 3 times square root 3, isn't it? 9 is what? 3 times 3. They're going to separate this way. But we know the same number, square root 3, when you multiply, it's going to be 3. Square root 49, square root 7 times. I'm going to skip this one, okay? You know that. Square root 7 times square root 7 is going to be 7. That is the square root numbers. Square root 25 equals square root 5 times square root 5. That's why this value will be 5. Square root 10, this is also what square root 1 times square root 1, right? Because the 1 is 1, 1 times 1. This is also 1. 121 is square root 11 times square root 11. That is 121. Same number is going to be equals 11. Square root 0 is 0, okay? This is 0. Same. Square root 2 is what? 2 times 2 is what? Square root 2 times square root 2 is going to be 2. 64 is square root 8 times square root 8. Same numbers. It's going to be out 8. Then just square root simplify. So where is this round number? Square root 14. Okay, maybe you can approximate where is this number. Using your calculator, you can find out. Or square root 14 greater than what is the square root? What? 9, isn't it? 3 squared, 9. And 4 squared is what? 16. Between this number, we know that 14 is greater than 9 and less than 16. But this number is how much? Square root 3 times square root 3 is 3. Actually, this number is 3. The other number, how much? The square root 4 times square root 4 is what? 4. That means what? This number between 3 and 4. Now we actually, what is this number? You can use a calculator, okay? Just 1 minute. Oh, down over here. Can you see the calculator over here? Let me see. Okay, you can see the calculator, right? All right, square root, you can use what's over here. So okay, I'm gonna clear square root over here. 14. 14 equals how much? Yeah, 3.74 inside 3 and 4, right? That's the square root numbers. Okay. Just approximate, or you can use like perfect square numbers. 52, where is this numbers? 52, we know that greater than 49. 49 is a perfect square number. The next one is a squared is what? 64, isn't it? So this number greater than 49 but less than 64. when you make a square, it's the same thing. Square root 52 equals, now greater than 49 is what? 7 times 7, square root 7. Square root 7 is 7. This is square root 8 times square root 8 is 8. This number between 7 and 8. Are you guys with me? 167, that's a perfect square number. No, that is not perfect square number. Very close to perfect square number is, what is that? 13 square is 169. 12 square is 144. This number between these two numbers. This is 12. 167, that is 13. This number must be between these two numbers, approximately. Is it okay? Something like that. That's enough. Some of this one will be on your homework, okay? Now almost done. Oh, done. We're done, right? Excellent. But this is why I'm not going to do this one, okay? Word problem. Just understanding what is the square root, okay? All right. After this class, okay, I'm going to send out the homework. We finish exponent and square root today, okay? Next Thursday, we're going to have, right, probability or some other topic. Let me check it out. Okay? All right. Now, let's finish today. I'm going to send out via your homework after this class. Okay, so just try to figure out what is a negative exponent, okay, or exponent operations, okay? Especially when you have a negative exponent, how to change positive exponent and what is the square root, okay? So we can, we might have some summary, okay, next time about this way exponent, okay, and square root. Okay, that's all today. I'll send out your homework after this. Okay? Okay. Also next time, thanks for joining the class. Okay. Bye everybody.
Bye.
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 Bye everybody. Thank you.